Hey everyone, Andrew here. I've received a lot of recommendations from those who have watched my Laravel Docker tutorials for a video showing how to deploy a Laravel app built with Docker to a production environment. So that's what I'll be showing in this video today. You'll see two different ways of deploying a Laravel app to an external server and getting your site live in a matter of minutes with Docker and Docker Compose. So let's get started. What I have here is a super basic Laravel application that I threw together for this demonstration. It's a list of posts, and I can click on a title and see the content for an individual post. There's a database seeder and factory class for the posts that I can call with artisan as well. So it's pretty simple, but it uses a lot of basic components that a standard Laravel app might have. In order to deploy this app, we'll be making use of Docker Compose, just like we use with our local environment. However, if we take a look at our current Docker Compose file, there's a bit of an issue with the setup. Running this one exposes the Nginx web server on port 8080, and we can see that in the browser when we visit our development site. This works great for our local installation, but if we were to deploy it like this, we'll need to specify the 8080 port at the end of the domain in order to access the site. What we need to do here is expose the port that our web server and browser naturally expect, 80. We could do that with this file, but I'd prefer to keep my local environment set to 8080, so I'm going to copy this file over to a new file called dockercompose.prod.yml and adjust the port accordingly. This way, we have that separation between our local development environment and our production environment. The other thing that we'll need to adjust is the MySQL passwords. Since this application will be available to the public, we should use more secure passwords than just secret. Okay, that's better. Everything else looks good and should stay the same. We're going to be deploying these on a DigitalOcean droplet. It's a service that I've been using for years in all of my side projects and just genuinely enjoy what they offer. The following steps from here on out shouldn't matter if you decide to use a different host, as long as you're able to SSH into the server and perform sudo commands. I'm going to create a new droplet with the latest LTS version of Ubuntu, 18.04.3. It'll be a standard flavor and the smallest partition. This should be plenty powerful for our application. The location looks good, and I'll use my SSH keys. And we'll set the host name to Docker Laravel 01. Alright, let's wait for this to spin up. And it's ready. We can copy the IP address, and we can verify that it's up by SSHing into it as root. While we're in here, we can complete our first step. Let's add a non-root user with sudo privileges. We'll call this user Laravel, and set a password for them, skipping through the rest of the details asked. Then we can add them to the sudo group using usermod ag, followed by sudo, and the username that we selected. Okay, perfect. Let's back out now and back in to refresh that user and create a new folder in their home directory that our site will live in. We'll just call this the same as our development directory, laraveldocker.test. Now let's exit the session and talk about our deployment options. For this first method, we're going to use rsync. This command is available natively on macOS and Linux systems, but you'll either have to install a third-party program for Windows or use an alternative like FTP or CWRsync. So the syntax for rsync is pretty simple. It's rsync followed by any options, then a source location, and the destination. You can use this to copy between folders locally or from a local machine to a remote machine, which is how we'll be deploying this site. So let's do it. rsync, and our options are A, which sends all files and folders recursively throughout our entire source directory, V, verbose, giving us a good amount of console output as it runs, Z, which sends the files compressed, saving bandwidth and transfer time, and H, which transforms any byte values into more human-readable formats. Since we're in our Laravel docker.test directory on our local machine, that's our source, and our destination will be prefixed with the username and the IP address of our server, followed by a colon, and then the complete path to our remote Laravel docker.test directory. Let's hit enter and watch it go. Alright, everything's transferred over. It's quite a lot, but that's because I didn't use something like filter, which could have removed the node modules directory, since that's only being used in our local asset development. Oh well, let's press on. SSH back into our server, and since all of our files are here, we can get started installing Docker. I'll be following this article from Brian Hogan, and we'll just go through step by step. Our prerequisites are met. We have a server running Ubuntu 18.04 and a non-root user. I didn't set up a firewall for this demonstration, but it's recommended to keep your non-used ports closed off from the outside world. Okay, first things first. Update our package list using sudo apt update. Then install some prerequisite packages. Next, adding a GPG key for the official repository. Actually adding in the Docker repository to our apt sources. Updating the package list yet again. And then ensuring that we're installing from the Docker repo instead of the default Ubuntu repo. Okay, that all looks right. Finally, the last thing to do is actually perform the installation. Once that's finished, we can verify our Docker service is up and running using systemctl. Perfect. Our second part to this installation is getting Docker Compose set up, and I'll be using this guide from Melissa Anderson. By the way, if you would like to check them out, both this and the previous Docker installation guide I've linked below. Okay, our prerequisites look good, so we'll just go down the list of commands like the previous tutorial. First off, grabbing the release file using curl, then setting some permissions so it's executable, and finally, we can verify the installation using Docker Compose version. That's honestly all there is. So, let's navigate to our sites directory in our server and get started. Just like when we bring Docker up locally with Docker Compose, we can use Docker Compose up with the D flag, so it remains running in the background. But there's a catch here. We're using a separate production Docker Compose.yml file with the modified ports from earlier. If we just ran Docker Compose up, it'll use the default Docker Compose YML file. To get around this, we can pass in the F flag first, and specify the Docker Compose file, or files, that we want to use. In our case, dockercompose.prod.yml. Then we can proceed with the rest of the command as usual, up, d, build. Uh-oh, it seems like we ran into a problem. Well, we know that Docker is running, we just saw the service earlier. Let's use docker info and see what it returns. Okay, permission denied while trying to connect to the Docker daemon socket. Alright, so I found out what's causing this, and it's because our Laravel user that we created earlier isn't a part of the Docker group. We can fix this with a few simple commands. First, by creating the group if it doesn't exist. Then adding our Laravel user to the group using usermod ag docker. And to refresh these changes, we'll log out and log back in as our Laravel user. Alright, time to see if that worked. Perfect. Docker info is displaying back the information that we're expecting. Now it's time to try to bring up our Docker Compose network on our server. Just like before, we're using Docker Compose with the F flag and our production file, then up, D, build. Everything seems to have spun up fine, so that's great. There's just a few tweaks that we need to do before we can actually visit our application. We changed out the MySQL database password earlier, and so we'll have to open up our apps.env file and make the change there as well. Okay, now if we go to our sites folder on our server, we can run docker compose ps and view all of the containers that are running for our application. Everything is contained within these Docker containers. We haven't installed PHP or Nginx or anything like that on our actual server. So if we need to run a migration, for instance, we'll need to rely on our artisan container. That's exactly what I'm going to show you now, because we need to get our database prepped and seeded for our application. By using docker compose run with the rm flag, we can specify a container to act as its namesake command, and it will auto-destroy itself once it's complete. So for our migration, docker compose run, rm, artisan migrate takes care of that. The migration finishes just like it would if we were using PHP installed on our actual server. I mentioned earlier that I set up a factory and seeder classes for the posts. So let's put those to use. Docker compose run, rm, artisan, db, seed, class, post seeder. Seeds our database with 20 random posts. Okay, it looks like that's finished up. So now we can visit the IP address of our server and we should be able to see our app. Beautiful. Our posts are all here and we can even click on them and visit the individual pages. There's no additional dependencies to install or software to configure on our server. And because it's running in detached mode, we can exit our SSH session completely, and the site is still up and running. So with this deployment method, what if we wanted to make a change to our site? How would we go about doing that? Well, let's change this section here on an individual article. We'll go into our Blade template and make the adjustment. We can see that change in our local version, but not on our deployed production one, which is expected. Just like we did when we initially deployed our site files, we can use rsync to send over the changed file, or files, to our server. By default, this should only send over the files that have been modified since our initial deployment, but let's see what happens. Okay. It looks like our change has been published successfully. Although, unfortunately, even though I didn't record it, this process did mess up the permissions and .env file on the server, and they needed fixing. Moving on, I'd like to talk about a second method of deployment, and it's the one that I prefer. Before we do that, we'll have to bring down our current production site and start over. SSH into the server, and we can run docker compose down to bring down the container network. That's verified by then going to our server's IP address in our browser, refreshing, and seeing that our application doesn't exist anymore. There's nothing at port 80 that our server is responding to. And if we list our containers with docker compose ps, it returns an empty table. We'll also go ahead and remove the entire Laravel docker.test directory, including its contents, and rebuild it as a blank directory. Okay, I've exited the session and we're back on our local machine. This time, I'm going to deploy with Git and GitHub. We'll initialize the root directory as a Git repo by running git init, and then commit all of it by using add, and commit am with a simple message. Right now, we don't have anywhere to push that commit to, so let's set up a new repository on GitHub. I'll just call it video Laravel Docker deployment and add in a short description. This is a public repository, so you'll be able to check it out if you'd like, but this method will work for both public and private repos. Our next step in pushing out this repo is setting the origin. And then finally, we can run the push. If we refresh the repo page on GitHub, we can see our site's entire source code here. You'll notice though, there's no vendor directory. There's also no .env file. This is intentional and part of the default gitignore that Laravel comes with. PHP vendor dependencies are handled by Composer on each environment, and the .env file might contain API keys or passwords that shouldn't be committed, regardless of a repo's visibility. That's fine though, we can handle both of those from the server. Speaking of server, let's get this deployed out. We'll SSH back into our server, and navigate to the Laravel docker.test directory. And then we'll clone the entire repo to the current directory using the SSH method. Could not read from the remote repository. Using this method, GitHub compares SSH keys from the machine making the request, our server, to the GitHub repository. One doesn't exist for our server, so we're denied read access. Adding one is an absolute breeze though. Let's head back to our repository and go to Settings, Deploy Keys. Any remote machine that would need access to our repo should have an SSH key added in here. We'll title this simply Remote Server, and we'll need a key to paste in this box. Your server might already have a key pair set up in your user's home.ssh directory, but this one doesn't, so I'll create one now. SSH keygen t rsa takes care of that. I'll save it to the default directory and leave the passphrase blank. Then I can use cat to display the public key. That's the id_rsa.pub, and paste it into the appropriate text box on GitHub. Let's save that, go back to our server, and try the git clone again. It works! All of our files are now available in the site directory. Remember before about that .env file missing? Let's take care of that now. I'll just copy and paste the one from our local development environment into our server. But making sure to change the MySQL password to the one that we set in our production Docker Compose file. That's looking good, so it's time to bring up our Docker container network. Again, using the F flag to specify the production file, and running up d build. Let's visit our site. That's right, we're missing our vendor directory. Another problem that can easily be solved using Docker Compose. Just like with Artisan, Composer is another container that we've included in our network for use with this application. So instead of how we'd run Composer install if it was set up locally, we can use Docker Compose run rm composer install to utilize that container and have it do the work for us. We'll also run our Artisan migrations and database seeding at this time too. Let's see if our application's working now. Perfect! Everything has been deployed successfully, and our app is working just as expected. But what if, like our last deployment, we wanted to make a change to our app? Well, let's go back and revert what we did previously. Saving it, we'll then commit these changes in Git. And push that commit up to GitHub. Once that's done, we can go back into our server to our site's directory and run git pull. That's it. That'll pull in our changes that we've made, and they'll be instantly available on our app. And that's all for now. You've learned how to deploy a Dockerized Laravel application to an external server and get it running using Docker Compose. You've utilized rsync and GitHub to initially deploy a site and then make changes to that same codebase. As always, if you have any questions, please feel free to reach out to me in the comments or on my Twitter, which I've linked below. Huge thanks to my Patreon subscribers and everybody else who supports these videos. Thanks for watching.